This is a live view of the Earth from a distance of 15,000 miles away. About 3 hours and 40 minutes ago, Orion conducted the final major maneuver of its mission, a return trajectory correction burn of its thrusters to further fine-tune its path toward its splashdown site in the Pacific. We'll be heading out to the Pacific shortly for the first in a series of reports from the scene where Orion will be recovered. After launching atop the Space Launch System more than 25 days ago and traversing some 1.4 million miles in its circuitous orbit past the Moon and back, the most critical phase of the Artemis 1 mission for Orion is at hand. It is homecoming day, so let's run down the milestones you'll be hearing about and seeing over the next couple of hours. Next up for Orion will be the crew module's separation from the European service module. That pyrotechnic separation is scheduled at 11 a.m. Central Time, just 20 minutes before Orion begins its entry into the Earth's atmosphere at an altitude of 3,200 statute miles. Now, we had planned for Orion to conduct a maneuver called the raise maneuver, a 16-second thruster firing to orient itself at the proper angle for its plunge back into the atmosphere. But the latest targeting for Orion from the flight dynamics folks here in Mission Control indicates such a precise trajectory for the spacecraft, it was determined that the raise maneuver was not required. That could still change following crew module, service module separation, but at the moment, the raise maneuver will not be required. The major objective of this mission is to test the spacecraft's heat shield against the searing heat of entry, where temperatures will build up to around 5,000 degrees Fahrenheit around Orion, half as hot as the outer surface of the Sun, twice as hot as the temperatures endured by returning space shuttles and other crew vehicles. Orion will perform what is called a skip entry, dipping into the atmosphere, then lifting out of the atmosphere and dipping back in like a flat rock skimming across a pond. This will provide aerobraking for the vehicle, will help to dissipate some of the vehicle's inertia, and will provide data needed in the future to select multiple splashdown sites for crewed missions. We are expecting 2 periods during entry when the buildup of heat-generated plasma around Orion will block communications and the receipt of data with flight controllers here in Houston. The first blackout should begin around 11:20 a.m. Central Time for just under 5 minutes, right around the time of peak heating on Orion, as it travels about 25 times the speed of sound. The second blackout period is expected around 11:29 a.m. Central Time for just under 3 minutes, right after the skip entry maneuver is complete.